This is Mark Anderson for Kellogg Community College, and we're going to be looking at a second part of finding zeros of quadratic functions. And as mentioned in the previous video, there's a couple different rules to go by. Rule number one is you should probably try to factor the problem if possible, because factoring is the fastest way to find the zeros or the intercepts of the quadratic function. A lot of times things are not factorable, so we're going to use the quadratic formula. And once we exhaust all of our factoring and quadratic formula options, we will probably have our 0, 1, or 2 intercepts of the problem. And then that's going to tell me that we can write them in the intercept form, which is going to be where the x is going to be the first number of the two-digit parenthesis, or the two-part parenthesis. And again, I've said we'll have like 0, 1, or 2 solutions, and those are real solutions, but we're just at a point now where we can actually deal with imaginary solutions too. So in the 6 examples you'll see today, you'll see me factor, use the quadratic formula, and then get things into the intercept form. I also said in a previous video you can graph, and graphing does work, and it works very well if the zeros are integers. And you can verify that on the table, but only on one of these problems, one of these 6, are the answers actually integers. So for the other 5 problems, we'll definitely use factoring or the quadratic formula to help us out here. So let's begin by looking at this problem. Let's test to see if it's factorable. This is a tricky trinomial, so we're going to multiply 3 times 1 to get 3. And now what I'm going to do is try to figure out 2 numbers to multiply to make 3 and add to make negative 4. So that would be negative 3 and negative 1. Because these 2 numbers multiply to make 3 and they add to make negative 4. So I can split this up into negative 3x and split this up into negative 1x, plus 1 on this side and the 3x squared on this side. What I'm going to do is do some factoring here. This is a grouping skill where I'm going to group the first 2 terms here by factoring out a 3x. This leaves me with x minus 1. And here I'm going to factor out a negative 1, which leaves me with an x minus 1. And from the grouping, if I do get a pair, I can put those together in kind of a reverse distribution property. And the ones that are left on the outside, the 3x minus 1, become their own pair. And if you FOILed this, it would then make this trinomial. But what this allows us to do, as we're trying to find the zeros here, is set each of these equal to 0, like so. And if I solve for x, I will now get my answer to the problem. So if I divide both sides by 3, my answer in this problem is x is equal to 1/3. And if I was going to write that in the as a 0 or as an x-intercept, it would be 1/3, 0. Now finding the other one is a little quicker, because x minus 1, if I set that equal to 0, I can just move the 1 over by adding 1 to both sides. So my other answer is 1, 0. So here are my 2 answers for the zeros of this quadratic function. And the second example goes as quick as well, because this is completely factorable using easy trinomials. Like with the 1 in front of our x squared, we just have to look at what 2 numbers multiply to make negative 12 and add to make negative 1. In this case, it's x minus 4 and x plus 3 equals 0. Now I'm going to set these equal to 0. X minus 4 equals 0. X plus 3 equals 0. Subtract the 4 from both sides. Subtract the 3 from, add the 4 to both sides, and then subtract the 3 from both sides. And so my answers are 4 and negative 3, which means that these will hit the ground at 4, 0 and negative 3, 0. And you can see that this would be the only, out of these 5 examples I'm going to do, this would be the only one that I could have done just by graphing it. By plugging it into the y1 of a calculator and check to see on the table and the graph itself that it intersects at 4, 0, negative 3, 0. It would have been hard to determine that this intersected at 1/3 because your table isn't moving by thirds. And also it's kind of tough to see from the pixels on the screen where that would actually cross between 0 and 1. So with that in mind, I really do strongly recommend factoring and using that, instead of the calculator. But for the next 4 problems, we're going to see examples that cannot factor. So unfortunately, we're going to have to use the quadratic formula. And I say unfortunately because it's a little slower, but it should be good to say that if you are proficient at your calculator skills and actually substitution, you should do pretty well here. Because if I now have identified my A and my B and my C, these are the coefficients in front of the x squared and the x for A and B, and the term by itself is C, we can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Be careful when you're typing things in. For example, the negative b is negative 3 plus or minus the square root. And as good practice, always put your b, a, and c in parentheses, especially when typing this into a graphing calculator. That way, the negative signs get processed correctly, especially when it's being squared. And I've made several videos explaining why negative 3 squared with parentheses is different than negative 3 squared without parentheses. All over 2 times a, which is 2 times negative 1. So if I do some simplification, this is going to be 3 plus or minus the square root. By typing all of this in, this gives me negative 7. And this is divided by negative 2, and I split that up because each of these is getting divided by negative 2. Now, to do more simplification, this would be negative 3 halves plus and negative 3 halves minus. Now, this square root of negative 7 is the same thing as saying the square root of 7i. Notice that the I is not inside the square root. Also, some books will put the I in front of the square root. Divided by negative 2. Negative 3 halves minus the square root of 7i divided by negative 2. And these are your 2 answers, as we've now split up the plus or minus. Now what I can do is use the parentheses and show you that these are the exact answers, be it imaginary answers, to where this would hit I say hit the ground, but really these are the 2 answers in terms of their intercept, but they are imaginary. So you kind of have some good debate about where that would technically be on an imaginary x-axis, or an imaginary axis in general. Now, one thing I should note is that if you look in the back of most books, they won't have this answer with the second part of this under a negative 2, because adding a negative 2 is the same thing as subtracting. And subtracting a negative 2 is the same thing as adding. So it's more likely that you will actually see this answer without the negative signs being here at all on the problem itself, because a plus negative would be minus and a minus negative would be positive. So if you see in the back of the book that they don't actually have negatives under here for the second fractions, but here for the first fractions, you can email me and say, hey, looks like the back of the book is wrong, but in fact they just went an extra step. And depend on how severe I want to grade, I might make you do that simplification step too, but that's just to show you that the answers are equivalent. It's just that these might be just a little bit more simplified than the others. Alright, so let's go check out this. Oh man, there's no 2 numbers to multiply to 8 and add to make 4. So quadratic formula again, a is equal to 1, b is equal to 4, and c is equal to 8. Quadratic formulas are really the best way to do the problem if you can't factor it, and I strongly suggest this over completing the square, just because you've probably had more skill at it. So here's our negative b plus or minus our square root of b squared minus 4 times a times c, all divided by 2 times a, which is 2 times 1. So if I did some simplification, this would be negative 4 plus or minus the square root of negative 16, all divided by 2 times 1, which is 2. So I'm going to simplify the negative 4 halves as negative 2, which is kind of nice. And this numerator gets simplified to 4i, because the square root of 16 is 4, and the square root of negative 1 is I. So plus or minus 4i over 2 is like saying 2i. That's again 4i over 2. I've just converted this numerator to 4i, and then I can simplify that to 2i. So now I'm going to split this up. Split this up into negative 2 plus 2i, comma 0, and then negative 2 minus 2i, comma 0. And there are my 2 answers. For our final two problems here, we're going to work with more problems that cannot be factored. They're going to come out with some weird answers, be it imaginary or irrational. And yeah, you could factor a 2 out of this problem, but x squared minus 2 is not a difference of squares. So here is my quadratic formula input. But here's something interesting. You'll note that b is 0. There is no x in this problem. This binomial has an a in front of the x squared, no b, and the number by itself is c. So here we have 0 plus or minus the square root of b squared, in this case 0 squared minus 4 times a times c, all divided by 2 times a, or 2 times 2. So our first part is 0 divided by 4, which will simplify to 0. And then our numerator here is 32, if you compute that discriminant, all divided by 4. So what I have now is 0 plus or minus the square root of 32 over 4. The square root of 32 can be simplified into the square root of 16 times the square root of 2, or 4 square roots of 2 over 4, which also then converts to plus or minus the square root of 2. Now if I split this up, the square root of 2 comma 0 is one possible answer, and negative square root of 2 is another possible answer, which is approximately 1.41 positive and negative on the x-axis. Okay, so for this final problem, I can multiply 3 times the 4, and 3 times the 4 would give me a positive 12. But a positive 12 is never going to give me a negative 1. See, this is me trying to factor it, but see, I can't find two numbers that could multiply to make 12 positively and get a negative 1. Now, man, if that was a subtraction sign, we'd be in business. But unfortunately, it looks like this problem's unfactorable. So into the quadratic formula we go. Now, if you're ever wondering, like, hey, did I use the quadratic formula and I could have factored it? It mostly has to deal with the fact that if you do get two answers that aren't irrational, or two rational answers, if you get a fraction or an integer, then you probably could have factored it. But the quadratic formula will do this for you pretty nicely. The negative 1 is going to be my driver of the truck, plus or minus the square root. This looks like a little trailer here. This is going to be my b squared minus 4 times a times a c, all divided by 2a. So here we go, 2 times 3. So negative 1 is 1. Plus or minus, if I compute the discriminant, this is going to give me a negative 47. Yikes. All divided by 2 times a, which is 6. So now my two answers broken up are going to be 1/6 plus the square root of 47i divided by 6, comma 0. And my second example is going to be 1/6 minus the square root of 47i divided by 6, comma 0. And that is a little bit more about finding zeros or intercepts of quadratics. Thank you for watching.